Oh, good morning. So today we are going to go through the second lecture of the information technology subject. So today we are moving with the IT infrastructure. What is this IT infrastructure means? Any ideas? So first we need to identify the computer. When it comes to the IT infrastructure or information technology infrastructure, we know that IT can be work with the computer, right? So with the computer, we can't do our works properly. So the basic thing that we have to work with information technology is the computer. So first we have to identify the computer. So that's the IT infrastructure mainly. So first we have to identify what is those features of computers. What is the main things that the computer operates with? It has speed as well as it is having accuracy as well as it works with a logical way as well as it is computers are automated as well as it has a remembrance power as well as it is reliable. How is it? We all know computers are more speed more than human. So computers can operate more speed than the human. So computer as well as computer are always automated. It means it works without only we have to give the commands. It works automatically as well as computer works with some logics. It have a logicals. It means they are having some programs, they are having functions. So those are the logical way. As well as they are always accurate. It means they are giving the latest informations to us as well as it has a reliability as well as it have a consistency also. So those are the features of computers. So moving on, the computer has the main box. It is the central processing unit or CPU. So this is the control unit and also it's a arithmetic logic units. It has arithmetic logic units as well as memory unit also. The memory unit can be divided into primary memory and secondary memory. This is the CPU or central processing unit. It's a rectangular box inside the system unit. So first we have to identify the process of this uh, computer. So first we have to give there are inputs and outputs. So inputs are the keyboard, mouses, scans, and mics. Through those keyboards, mouses, and scans, we are giving data. So CPU is the uh, place where the inputs are getting proceed to give an output. So outputs functions are monitors, printers, or speakers. It means CPU giving a process input to a useful output. So this is the process in the functions of the computer. There are inputs as well as processing. It means the processor is the CPU and there are outputs as well. So, in the system unit, what are the components in the system unit? So, uh, house of the processing hardware of the computer is the system unit. It's a system unit consists with memory, power supply, and cooling fans as well as interfaces to connect uh, devices as well as. So, houses the drive base in which storage devices. There are hard drivers such as DVD drives, and there are some. Um, this is some kind of this system unit is a rectangular box. Rectangular box. So, uh, as you can see in the image, the system unit has CPUs, motherboards, memory slots as well as USB ports as well as DVD drives and drive bays and hard drives as well as fans. So So what these things are doing in the system unit, let's see. So the CPU performs the calculation and does the comparisons needs for processing as well as control the other parts of the computer system. So CPU is the biggest part in the system unit, as well as the power supply is also giving the electrical power into the form of computer can use, as well as there are some memory RAM. So RAM is the place that store data temporarily while you are working with it. We will go through this RAM in next slide. So memory, there are as well as there are memory slots also in this system unit. What is this memory slot? So these memory slots are the connect memory modules to the motherboard. So as well as you can see this, there are USB ports. So these are the connect devices to the computer. You can connect some uh, devices such as pen drives or uh, some kind of those kind of devices can be connected to the computer use these USB ports. So as well as there are some DVD drives as well as drive base and hard drives. So the hard drives are the store data and programs, the principal store devices for most computers. So this is the inside of a system unit. So as I earlier mentioned, CPU does the biggest part, right? So CPU crucially and it's that's the vast majority of processing for a computer. Also, this is a processor or microprocessor when talking about the PC. So this is can we can earlier as I mentioned, this is the core of the core CPU. So originally CPU has single processing core. Today modern CPU consists of multiple cores that allows it to perform multiple instructions at once. It means there can be single core as well as multiple cores. So single core has doing works more than it means if there are multiple cores, we can do more functions. It means do multiple instructions at once than the one core. So multiple cores are better than one core. So that's the basically thing. If the computer has one core, it is not that much speed or it's not that much um, reliable uh, to work. If you having multiple cores in your CPU, it's more uh, faster than the one core CPU. So that's the main thing you have to memorize in the CPU course. So a core can work on one task while another core works a different task. So the more cores a CPU has, the more efficient it is. So as a as a as as a summary, we can say if there are more cores, there is more efficient. So if one core it's not that much efficient. So there can be dual core or CPU as well. So dual core CPUs contains the processing components of two separate processors on a single CPU. So there can be two separate processors in a single CPU. These are the dual core CPUs. So as well as there can be quad core CPUs. What is that means? Earlier I mentioned dual core. So there are two processors, two separate processors. Then I am talking about quad core CPUs. So there are four cores separate in the CPU. So typically designed for desktop PCs, portable PCs or servers. So often made by Intel or AMD. So these are the companies who offer these CPUs. There are Intel and AMD who manufacture those CPUs. So moving on, there are some types of CPUs. There are servers, desktops, mobile devices. So there are some names with the CPUs. So the server CPU is Intel Xeon uh, E7 family. So there are 4 to 18 cores in the server CPU. And the desktop CPU, it can be Intel Core i7 6th generation. So there are 4 to 8 cores in that CPU. As well as when it comes to the mobile, for the mobile CPUs, it can be Intel Core M or Intel Atom 7, Intel Celeron. So there are 2 to 4 cores are inside this CPU. So as you can see, when it comes to the devices are getting smaller, the cores are getting reduced, right? So in the desktop, there are only 4 to 8 cores. But when it comes to the mobile, the cores are only 2 to 4. Because what? The size is getting smaller. So the cores are also getting reduced when it comes to the size of the CPU is getting smaller. So in a mobile device, there can be only 4 cores in the mobile phone devices. So this is the with the CPU, the number of cores are getting different. So based on the device, number of cores are getting different. So that's the basic idea about the CPU and the cores. So as I earlier mentioned, CPU is we all know that computers device is represented by numbers. You can think of CPU as a calculator that runs incredible fast. So there CPU has two sections. First one is arithmetic section and logic section. So first one is arithmetic section. What is this arithmetic section? So arithmetic section is function of arithmetic section is to perform arithmetic operations like addition, subtraction, multiplication, and divisions. All complex operations are done by making repetitive use of the above operation. So repetitive functions, mathematical functions are done in this arithmetic section. So in the logic sections are the place where that they are getting decisions. Perform logic operations such as comparing, selecting, matching, and merging of data. So in the arithmetic section, doing all the mathematical parts. In the logic section, all the decision parts or operations parts are done in this logic sections. When it comes to as an example, if we said we want to get the GPA of a student in our batch, so the GPA is a calculating GPA is an arithmetic process. So it's doing by the arithmetic section. As well as if the computer wants to get the class of the uh, or the position of the student is a logic section. How is it? So after calculating the GPA, you can identify it's getting giving a number. So that's the decision that we are going to take based on that number. So it's done by the logic section. It means it's comparing, selecting, matching, and merging of data. So it's matching. What is the position that the student having get, as well as it's selecting. What's the place this student is uh, having in the class. So as basically the mathematical parts are done in the arithmetic section, and the decision makes are doing in the logic sections. Hope you understand in this CPU sections. So in CPU components, there are main three components in CPU. First one is arithmetic and logic unit. It performs all calculation, operating or binary data with the arithmetic and logical functions, as well as there are control unit. It's mainly fetch and interpret instruction from memory, deciding what action has to be taken. When it comes to the third component, it's a register store. Very fast memory provides temporary storage place for data and instruction. So it can be a control unit or ALU. So there are CPU have three main components. First one is arithmetic and logic unit, and the control unit and register storage. So control unit is the place the part that the memory the actions has to be taken, and the register store is the fast memory provide temporary storage place in the data and instruction. So as well as I earlier mentioned, arithmetic and logic unit perform all the calculations and operations with the given data. So these are the CPU components in a as I earlier mentioned. So as well as the components, there are some CPU slots. What are these CPU slots? So LGA and PGA are the main slots in the CPU. What is this LGA? The PGA. So LGA is mean the land grid array. And the PGA is mean the pin grid array. So what is the difference between this land grid array and pin grid array? So the land grid array is the consist of a socket with pins that you place the processor on. So the socket has the pin in land grid array. So pin grid array, the processor having the pins. So that's the main difference in between land grid array and pin grid array. So land grid array, the sockets having the pins, and the pin grid array, the processor having the pins. So this is the main difference in between the land grid array and pin grid array. So then we move on to the processing speed. First we have CPU slots. Then first we have identified CPU components. Then we move on to the CPU slots. Then we are going for the processing speed. What is this processing speed in CPU? So CPU having a clock speed. It's the CPU clock speed. It means one measurement of processing speed. So the CPU measured in gigahertz or megahertz. Alternate measures of processing speed is the number of instructions a CPU can process per second. So it can be a megaflop, gigaflops, or teraflops. So processing speed is a number of instructions a CPU can process per second. So processing, now there are the CPU can process a large number of instruction per second. So this is the processing speed. So as you can see, the processing speed is the instructions a CPU can process per second. So it is a huge number. It can be megaflops or gigaflops or teraflops. So the measured in the CPU speed measured by gigahertz or megahertz. So when we come to the how fast CPU can execute instructions means we can say measured in gigahertz or billion cycles a second. So as an example, we can say 2.4 gigahertz or 3.2 gigahertz. Uh, Mostly, the CPUs are either 22 bits or 64 bits. This means how much memory that CPU can handle. So it means when it comes to 32 gigahertz for it, 4 gigabytes. So when it comes to 64 gigahertz, uh, 32 bits, it means 4 gigabytes. When it comes to 64 bytes, it means 16 extra bytes. So that is the main uh, memory that a 32 bits computer can handle, and the 64 bit computer memory can handle. So when it comes to 32 bit memory with a CPU can handle almost 4 gigabytes. When it comes to 64-bit memory with the CPU can handle 16 extra bytes in a computer. So hope you understand what is this CPU 32 bits and 64 bits. So when it comes to CPU naming, how the CPU naming have going with. So as I already mentioned, there can be a processor name and processor number. So you can see in this image, there is a processor name. So in here, the Intel Core i7 is the processor name. When it comes to the processor number, is the i7 7700K. So processor name and the processor number are the main part in a CPU naming. So let's move into the word size and cache memory. What is this word size and cache memory? So word size is the amount of data that a CPU can manipulate at one time. So usually it can be 32 bits or 64 bits. So in one time, it means CPU, the amount of data that CPU can manipulate at one time. So the either can be 32 bit or 64 bits. When it comes to cache memory is the special group of very fast memory chips located on or close to CPU. So, um, cache memory is the very fast memory chip located in between the CPU and primary memory. So we can say this in the cache memory, level 1 is faster than level 2 than level 3. So more cache memory typically means faster processing. Usually internal cache memory is one example for this cache memory. So in the summary, we can say that the level 1 cache memory is faster than the level 2 and level 3. So it's a chipset, faster memory chip located on or close to the CPU. You can see the cache memory is, as I earlier mentioned, is near or close to the CPU. So it's a special very fast memory chip set to it used for fast processing. Then we move on to the bus width or bus speed and bandwidth. What is this bus speed and bandwidth? So bus is an electronic path over which data can travel. So it's as it says, it's a path over path that data can travel. So bus width is the number of wires in the bus over which data can travel. As an example, as a uh, our day-to-day example, in a road, if there are two lanes. So these two lanes are we can refer as bus width. So the number of wires. So when there are in a highway, if there are two lanes or three lanes, so according to the bus width, what is it? The bus width is the three lanes. So the number of wires in the bus over which data can traverse. So bus is an electronic path over which data can travel. So bus width and speed determine the throughput or bandwidth of the bus. So bus width and the bus determine the bandwidth or speed. Bus width and the speed determine the throughput or bandwidth of the bus. So the bus can be directly connect with the bandwidth or the throughput of the bus width. So as the image you can see, it's a 8-bit bus. Why is it? So bus width is 8 lanes. So we can basically say it's a 8-bit bus. In here, in the second picture, you can see that there are 16 lanes. So this is 16 lanes are the bus width. So it represents as the 16-bit bus. So let's move on to the memory. What is the memory in the memory? What do you think? What is this memory? So memory refers to the chip-based storage. So we all know the memory in the computer is stored in the chip-based storage. So RAM is the first thing we have to identify in the memory. So what is this RAM? Random access memory. Earlier I mentioned that in this system unit there is a RAM, right? So as well as there we are moving with the broader in this RAM. So this RAM is the RAM temporary memory that the computer use consists of chips connect to a memory module which is connected to the motherboard. So it's connected to the motherboard. So it's a temporary memory that connected to the motherboard. So it can be a single inline memory module or dual inline memory module or rambus inline memory module. So these are the three types of memory modules. So first one is a single line inline memory module, or second one is dual inline memory module. The third one is rambus inline memory module. So in memory, hold data and program instruction while they are needed. In RAM, it's mainly hold instruction while they are needed. And it's adequate. RAM is needed to run program, and volatile. Content of RAM is lost when the computer is shut off. It means RAM is, as I earlier mentioned, it's a temporary memory. It's not a permanent memory. So if the computer shut off, if the computer shut down, the memory is lost. So that's the RAM. So random access memory having a temporary memory. So if the power off or shut off the computer, then memory is lost. So some form of RAMs are under development. So we can see that is the gap or future things that we have to consider. So there are some motherboards or motherboard forms. So in this picture you can see that there are 5 different motherboards. First one is standard ATX. The second one is micro ATX. Then the third one is mini ITX, and the fourth one is nano ITX, and the last one is pico ITX. What is the difference between these five? So as you can see, the standard ATX, it means with the picture you can see it's very large than the micro ATX. So this kind of standard ATX are mainly using for games, gaming computers. So they can function more completely. So within this kind of stand ATX are uh, they having more functions. So it's for process with more functions. They need a big space. So standard ATX are mainly using for gaming computers. So micro ATX are smaller than the standard ATX. It means it's only needed for some needed components. So such as personal computers or laptops, some not laptops. So personal computers are used this kind of macro ATX. It means we need only some sort of only needed components in this motherboards. When it comes to mini ITX, it is smaller than the micro ATX also. So the components inside the motherboard having get smaller as well as reduced. So it means it's useful for its works with its having more needed components. So these are so the nano ITX and pico ITX are getting smaller, and as well as their speeds are getting faster also. When it comes to the motherboard, so this is the forms. There are standard ATX, micro ATX, and mini ITX, and nano ITX, and pico ITX. Next, we move on to the inside of the motherboard. What are the components inside this motherboard? What do you think? As you can see in the image, there are a lot of components in the motherboard. What are those? So there are some CPU, zip sockets, fans, secondary power, back fan, connectors, or CD auto connectors, so CNR risers, as well as USB 2.0 risers, and a lot of things are in this motherboard. So uh, then we move on to the system case. So what are the components in the parts or components in the system case? Is as well as you can see the motherboard have different parts, right? Than the system case. So what are the parts in the system case? So there are some power supply cooling fans as well as power connectors, VGA ports, USB ports, as well as thumb screws, expansion slots, security lock ports. So those are the parts of a system case. You are not needed to memorize them. You have to identify what are the parts in the system case as well as the motherboard, not with definitions. You only have to uh, get an idea what are the parts, not with explanation at all. So next we move on to the chipset. What is this chipset in a computer? When a new processor is developed, a new chipset has also to be developed uh, to accommodate its technology. If the processor is the brain, the chipset is the spin and nervous system in the computer. The chipset is responsible for facilitating communication between the computer processing unit, CPU, and the various components. So on the motherboard, acting as a traffic cops and the controllers. So the chipset has two components, north bridge and south bridge. What is this north bridge and south bridge? So north bridge is mainly focusing on the main components, and the south bridge are working with the other components. So mainly North Bridge works with the main components. So as well as chipset act like a motherboard communication center and traffic controller, and it ultimately determine what components are compatible with the motherboard, including the CPU, RAM, hard drives, and graphics cards. So it also dictate your future expansion options as to what to do can be overclocked. So those chipset are doing a huge work inside the motherboard. It's mainly communicates and it has work as the communication center and traffic controller in the motherboard. So it works uh, It's worked with the CPU, RAM, hard drives. So these are the things that chipset work with in the motherboard. So so this is the chip. As you can see, the chipset works with the CPU as well as memory slots. Not only that, it's used with the USB audio keyboards, Ethernet card, as well as the PCI buses and video cards. So chipset done a huge work inside this motherboard. So I hope you have understand the main features in the computer and how the CPU works. So as I earlier mentioned, CPU is the main function in the computer. So inside the system unit, we can see the CPU. So in as I earlier mentioned, the CPU done the calculation and processing and decision making and a lot of work in the system unit, and this is the main brain in the system unit. So it is the vast memory of the processing for a computer. So that it can be a multiple cores or single cores, and the cores what the one core can do and the multiple cores can do, what is the quad core and the dual core, and uh, the types of CPUs when it comes to the server, desktop, and mobile phones, like that, the number of cores. So, what are the sections in the CPUs? Arithmetic section and logic section. What are the things that arithmetic section done as well as logic section done? We already explained. So, what are the three main components in the CPU, and what is this two slots LGA and PGA, how it difference? LGA having the pins in the socket as well as pin grid array has the pins in the processor. That is the main difference. So LAN grid having the pins in the socket, and the pin grid having the processor having the pins. So as well as what is this processing speed? So and what is this 32 bits and 42 bits, as well as how the what is this word size and the cache memory and bus speed and also memory. The mainly we identify what is this RAM. So what does the RAM does, as well as what is the different RAMs in the CPU RAM have, and what are the main factors or forms in the motherboard, and how it differ, and what are the forms it use, and we already identify the motherboard, the parts in the motherboard as well as the parts of the system case, and finally we identify what is this chipset also. So I hope you understand this basic first IT infrastructure lesson. So I'm glad to answer any questions if you have. So thank you for listening. Goodbye.